Hello everyone, my name is Divyam Agarwal from G138. Our project, Expression Tracker, Sentiment Analysis for Dyslexic Kid during Gameplay by Joy with Learning uses facial expression analysis to access dyslexic children emotions during educational gameplay, helping refine game design to enhance learning and emotional support. Now we are going to see the main components of our project, underlying data structures, user interfaces, and business logic. Components of our project. Here we have three components: image capture, image processing, and sentiment analysis. In image capture, the system collects images using a camera capturing the child's facial expression during gameplay. In image processing, the system analyzes the image to detect key facial features like eyes and mouth for a clear view of expression. In sentiment analysis, finally, the system classifies these expressions into emotions like happiness, frustration, etc. to understand the child's emotional response during the game. Datasets and data processing. Types of datasets. We use three main datasets: a facial expression dataset with labeled images that show different emotions for training the AI. Gameplay images capture children's reaction while they play. Lastly, emotion label provide preset example to help guide the model. Data processing. This involves two steps. Facial recognition detects and focuses on faces within the images. Then, sentiment analysis trains the model to identify emotion based on their expression. Here are some images of how we are storing the data. This is the MongoDB data structure in which we are storing a emotion like happy, sad, etc. and we are giving a score to it which shows the percentage of happy, sad, etc. and we are giving a unique ID to it. And with that we are providing the timestamp, means at which time the snapshots are taken. Technical stack. We use React in frontend along with CSS for styling. And in backend, we use Express.js and Node.js, which manages server logic, and MongoDB, which handles data storage. And in deep learning model, we use VIT facial expression model developed on Hugging Face. We are employing the Hugging Face interface API to generate a JSON file from the model, which provides the 5 most likely emotions depicted in an image along with their scores. We have adjusted the output format to store the result as an array in MongoDB. App roles and interfaces. Here, admin manages content and data, while the game designer optimizes game elements based on emotional impact reports. The child interacts with the user-friendly game interface, receiving supportive feedback tailored to their emotions. Together, these roles and interfaces enhance the educational experience for dyslexic children. Input screens. Here we have some input screens like login screen, in which a admin or a therapist can log in and see the emotions of the child. And we have a game screen which is played by the child, and at every 10 seconds the snapshots are taken while the child is playing a game. Output screens. Here are some images of our output screens. As you can see in the admin interface, we have given session ID, student name, game name, and a timestamp. When an admin or therapist want to check the emotion of a child, they can click on analyze and they can get the emotion with percentage. And this is also shown in the form of pie chart. By this pie chart, an admin or therapist can easily understand the emotion of a child while they were playing a game. Workflow of our project. Here we have two interfaces, child interface and admin interface. In the child interface, when the child plays the game, the snapshots are taken. These snapshots are sent to the server using Express.js, and at the server these snapshots get stored. Coming to admin interface. Here, when the admin logins and trigger analysis, a API call is made in the middleware to receive snapshots. These snapshots are sent to the deep learning model. Here, the snapshots get analyzed and feedback is prepared. This feedback is sent to the database. And in database, this feedback is stored. And this feedback is shown in the front end in the form of pie charts, graph, etc. Business logic of our project. Emotion mapping. This connect detected emotion with specific game elements to identify recurring emotional responses. Feedback mechanism provides real-time adjustment such as calming elements if frustration is sensed. Analytics generation measure engagement levels, track emotional frequency, and analyzes intensity trends to refine the game experience. In conclusion, our project sets the foundation for developing a system that effectively enhances the learning experience for dyslexic children through emotional insights. Thank you.